Video, we're going to talk about frequency tables. Frequency tables are a type of table that is used to organize data by grouping the data and counting the number of data values in each group. Sorry, I had a little brain fart there. So typically frequency tables are used with numeric data. When we have a long list of number data, we wanted to put it in groups. We can also use frequency tables for categorical data, but we won't need to do the grouping step. So for all frequency tables, we're going to need to count the number of data values in each category or group, but we really only need to worry about the grouping step for numeric data. If you scroll down a little bit, you'll notice down here where we have the how-to section, those first two steps are marked with green to indicate that if you are working with categorical data, you can skip those steps. Those first two steps only apply to numeric data. So let's go ahead and do an example of a frequency table for numeric data. So the very first thing we're going to do is we need to look at the data and figure out the structure of the table. How big do I want it to be? How wide is the data on a number line? So we're going to identify the min and the max in the data set. So I'm going to circle those in green. I see the minimum is 1, the maximum is 10. So I'm going to write that down here. And the other thing that I need to do is I need to decide how many groups I want for my table. How many rows do I want in my table? We call those groups classes. So when we say classes in statistics tasks, we're just talking about the groupings. Sometimes you'll also hear them called bins. All three of those words mean the same thing. And we have control over how many groupings we see in our table. I have two recommendations. First, you want at least 5, because if you have fewer than 5 classes, any patterns that we get from graphing that frequency table later are going to be hard to see. My second recommendation is you want it to be 10 or less. Once you get more than 10 groupings, the graph tends to become a little bit more difficult to read. The table starts to become large and unwieldy. So typically values between 5 and 10 inclusive are a good guideline. Looking at my data only goes from 1 to 10. I'm going to use 5 bins for this one. So I'm going to make my table with 5 rows. The next thing I need to do is decide on the class width, the gap between the rows. And to do that, we're going to take our max minus our min, and we're going to divide it by the number of classes. Once you've done that, you'll sometimes get a decimal answer here. You need to round that decimal up. If you round the decimal down, it's possible that your maximum value won't fit in that last row, and you'll need an extra class, one more than you wanted. So always round these guys up. And let's go ahead and do that for our data. So for our class width, our max is 10, our min is 1, and I want 5 classes. So that's 9 divided by 5, and I happen to know that that's 1.8, and I want to round that up to the next nearest whole number, which is 2. So I'm going to be counting by 2 in my frequency table. The next step is to make our table, and our table should have at least 2 columns, at most 4. every frequency table should have the classes listed. So if we're talking about categorical, we should have one column for those categories, and then a frequency column for the count, how many data values in each category or in each class. So these guys are required. These are what make a frequency table a frequency table. We often also see relative frequency and cumulative relative frequency. Relative frequency is percent. It looks at the class frequency relative to the total frequency. Cumulative means that we're going to keep a running total. And since it's cumulative relative frequency, we're keeping a running total of the percent. And you can see on the right, I've already set that structure up, class limits and frequency, and then relative frequency, cumulative relative frequency. And I wanted my table to have 5 classes. You'll notice there's 5 rows. 1, 2, 3, 4, 5. The next is to start getting our information into the table. So we start with class limits. And we put the minimum as our first value in the first row. It's the lower bound for our first class. And I'm going to fill in all of the lower bounds before I fill in the upper bounds, because my class width is the distance between the lower bounds in each row or the distance between the upper bounds in each row. So to fill in the rest of the lower bounds, I'm going to take the lower bound of that first row and add my class width. And then I'll repeat. Add 2 to that lower bound. Add 2 to that lower bound. And that will give me my next lower bound. So we started with 1, I add 2, I get 3, 5, 7, and 9 for my lower bounds. To get upper bounds, I want my table to be continuous, but I don't want overlap between the rows. If a data value falls or is counted in this first class, it should not show up in the next class. I don't want a double count, which means that this row should end right before this row starts. So if my second row is starting with 3, my previous row should end with 2. From there, I can figure out the pattern with the same method, adding that class width to that boundary to get the next row's boundary. So 2 plus 2 is going to give me 4, and then 6, and then 8, and then 10. And you'll notice my minimum is going to land in this first row and get counted here. My maximum is going to land in the last row and get counted here. So my data just perfectly fits in that table. The next step, we're going to do the frequencies. I do them with color coding. So I'm going to start with 1s and 2s. And I see 1, 2. I only see 2 1s. I don't see any 2s. And then my 3s and my 4s. Oh my gosh, I missed a 2. Mr. J. Look at that. There's a 2 right there that I missed. There are 3 in that first row. Now to the 3s and 4s. So 1, 2, 3, 4, 5. So I count 5 values between 3 and 4 inclusive. And then we'll do 5 and 6. So 1, 2, 3. I don't see any 6s, so just 3. and then 7 and 8. So 1, just 1. And then for 9 and 10, I count 1, 2, 3, 4, 5, 6, 7, 8. To check that I've done this correctly, if I were to add all of the values in that frequency column, they should add to the total number of data points. So going down that column, 3 plus 5 is 8, plus 3 is 11, plus 1 is 12, 12 plus 8 is 20. So this column adds to 20. If I go back up, this data set is a 5 by 4. 5 times 4 is 20. There are 20 values in that data table. So we did that correctly. If we also want relative frequency, we need to do that calculation. And relative frequency is going to be your class frequency divided by your total frequency. So for the first row, my class frequency is 3. My total frequency is 20. So my relative frequency is 3 divided by 20, which I happen to know is 0.15. We're going to follow that pattern. So the next row, my class frequency is 5. My total frequency is 20. And I happen to know 5 divided by 20 is 0.25. I see another 3, so that's another 0.15. This is 1 divided by 20, which I know is 0.05. And then I have 8 divided by 20, which I know is 0.4. The check that we did these calculations correctly is I know that if I've accounted for all my data, that should add to 100% or 1. So 15 and 25 is going to give me 40, 55, 60, and 100, or 1. So total number is correct, relative frequency is correct. Our last step is the cumulative relative frequency. So for cumulative relative frequency, we pull down the value from the previous row, and we add to it the value from this row. For this first box, there was no value above, so I'm just pulling over the 0.15. For my next box, I'm going to pull down the 0.15 and add the 0.25, which is going to give me 0.4. Repeating that process, 0.4 plus 0.15 is going to be 0.55. For the next row, I'm going to add another 0.05, which is going to make that 0.6. And then 0.6 plus 0.4 is 1. And we know we did this correctly because by the end of the table, I should have accounted for all the data in my set. That should always be 1 in decimal form, because all of the data in our data set is 10 or smaller. All right. If you have any questions, feel free to send me an email or drop by office hours. We'll be holding our first office hours on Thursday this week from 7 to 8. Otherwise, I'll see you in our next video.